Okay, so C++
Amazon.
templates are, basically templates come in two flavors in C++, function templates and class templates. So just a little definition, I think this one came up with Wikipedia. So 3 different definitions. So templates define family of classes and functions. C++ templates enable generic programming. C++ supports both function and class templates. Templates may be parameterized by types, compile time, constants, and other templates. This will all make sense in a second. C++ templates are instantiation at compile time. Okay, so here's like a little example. Suppose you found yourself in a situation where you wanted to write 2 functions, both with the same name, min. They take in 2 values. Let's say one version of your function takes in 2 integers and will return the smaller of the 2 integers. And the name of the function is min. So it returns an integer, it takes in 2 integers. This code, I don't know if you've ever seen this before, but this would compile as legal C and C++ code. This is basically right here saying, this is a true or false statement. Is A less than B, question mark. We're asking that. If it's true, return this, and if it's false, return this, separated by a semicolon. So this line right here is equivalent to saying, if A is less than B, then return A, else return B. But it's all done in one line. Okay, and then suppose you needed to have the same exact function for doubles. So you could cut and paste this one, cut it here, paste it here, and then everywhere you see the word int, you change it to double. So I'm just making it in purple so they'll stand out. So this is the only thing different, the double, double, double. Everything else is exactly the same. And if you wanted to do this for floats and other things too, you'd be doing a lot of cutting and pasting and changing words, right? So right off the top of your head, you start to think, well, this might be a common function for many different types. Wouldn't it be nice if I could write it once, right? So if you were to write it once, what would you have to do?
Make it generic.
Well, what's the thing that keeps changing? What keeps changing is the type.
Yeah.
The logic is all the same, right? So we'd have to somehow make the type like a variable or a parameter, something we haven't seen before. So off the top of your head, if you were designing a language to do this, what would you do? Would you put like an x here, like x min, xa, xb, and then somehow declare x can be anything?
Probably.
Yeah.
Something along that lines, right? You're going to substitute something in place of the type, and somehow alert the compiler that this is a type substitution. That's if somebody later on calls min and is not using like the x, they're using doubles, then it should be applied to doubles. It should be this version of it. Something along those lines. So the syntax they came up with is to go like this. So the above 2 lines, plus actually a lot more, because you're now doing this for all types, not just double and int, could be done like this. In C++, you have to announce to the compiler, I'm creating a template. So this is now not a function, but a function you could use to create functions from. So you're announcing with the word template. You're saying template and then class. This is like we were just saying the x, the thing that's going to be the parameter for the type. And most textbooks usually use the letter T. We could use any letter we want, but T, I guess, is because it's the first letter of the word type. So they use that as an example. So they're saying T is now a class, but a class, this might lead a little bit of confusion. Primitive types or classes can be used for T's. T could be an integer or it could be something you made up, like a fraction or a clock radius. It could be anything you make up. It doesn't have to be a class, it could be a primitive type. And now we're saying return of something of type. We're saying minimum, the thing coming in is the same as the type we're returning, and the second parameter is the same as the type we're returning. We're still saying if A is less than B, return A, otherwise return B. Okay? So now, this would work, if we now took an integer and said this integer equals minimum of two other integers, this would work. The reason it would work is because less than, which is something that, you know, the body of this has to make sense. Less than makes sense for integers. If you try to do this for some type where less than doesn't make sense, you're going to get a compiler error on this line saying I can't, you know, the compiler says I can't do a less than for whatever that type is. Okay, so again, this is a new keyword, template. You say in C++, you say template, then you build a list. This example just has one type, but we could actually build a list of types. And then write out the body of the function. And then just some rules on the, basically the template header is this part where we're saying template, and then we're saying class, and then we can make up some letters. In general, it's typical to use T. But then if you want to have more types to it, if your template might, maybe you take two floats and you return an integer. So then you would use a T and another letter, a T and a U, if you wanted to do that. If you want to take two numbers and then figure out which is the minimum one and then return it as a different type, then you'd say that, you know, T, min, U, A, U, B, something like that. Now you have more flexibility that the return type and the input types don't have to match. So we could just build a list if we wanted to. Okay, so then when you're calling a templated function as opposed to a normal function, it's exactly the same. So if we had the code from before and then we said we have an integer m22 and an integer m66 and a third integer min value, we can just write this line, min value equals the minimum of these two. Our template gives a definition for all types. At compile time, the compiler goes, it looks like you're trying to call a function min, its return type should be integer, which I'm getting from here, and its input type should be integer also. Since these match, it goes out at compile time to the template and says, I can build the corresponding function, the integer version of the function.
And just automatically determines that based on the declared value of the left side of that equal sign?
Right, as long as they match up.
Gotcha.
So, right, so as long as, well, what I mean by match up is that this type, and this type, as long as all three of these matched, if we use T, they'd all have to match. And then it would know, oh, this is the integer version of the min function, which was described in the template, because the template describes it for all different types. Then at compiler time, a decision would have to be made. Could the compiler perform all the functionality in the function? And the only real functionality was, can you figure out is one less than the other? And if so, then it would compile and run. So the integer version of the templated function would run here. So the call looks exactly the same. Like looking at this line, you can't tell if this is a templated function or a non-templated function. You'd have to actually look at the function definition. Okay. So, got two interesting questions. Suppose we did this. We have a long m equals 2 and a double n equals 1.8. And just a little reminder, a long is an int but twice as many bits, and a double is a float but twice as many bits. Okay, so this is an integer, this is, well, no, it's a long, this is a double. And we're storing the results in a float. And now we're going to run this line. Take a long, a double, figure out what the minimum is, and store it in a float. What do you think would happen? So what first, why is this like an interesting question? So what we said in the earlier definition, we used the same letter T. We could have done T, U, V, just going through the alphabet, and then that would work fine, right? Because it's okay that all three types are different. But when we made the template, we're insisting that the first two inputs and the return type all match. Now, does the compiler have a problem would the compiler would the compiler say there's a type mismatch, or, you know how sometimes the compiler does implicit cast? And says, all right, the types don't match, but I think I can handle it. What do you think would happen in this case?
We'll probably try it, and then if it doesn't work, it doesn't work.
Would it
I was
truncate
thinking an
the
error.
double and float to make them long?
Well, wait, so it would start casting one to the other?
I don't think so. I think
I
it would be
changed
an
it.
error.
Yeah, I think
Compiler error?
Yeah. Because don't they have to match?
I'm thinking you're gonna get it.
I feel like
Well,
if you try.
They don't have to match, but you lose precision on the
Yeah.
output, so it'd probably throw a compiler error, right? Because a float's smaller than a double, but it's essentially the
Yeah.
same.
Well, basically, if you tried to,
Would you lose
We're-
the decimal place?
I think that, well, the two choices are,
Because it is a
either it
float.
won't compile, or, you know, it'll compile with a warning saying there's a type mismatch, you might be losing decimals, or there might be round off errors. And if it did compile, then the question becomes, which one would get casted to which? Would-
Wouldn't they get cast to the return type float?
Yeah,
Like, what's the dominating, we have three different types, long, double, and float. If we're gonna start casting one to the other, who,
might
The
You're-
double.
might go with the
Float?
biggest one, double or
No, go to float
I would-
because that's what you're returning.
Yeah, that's what you're
Oh, yeah.
returning.
Yeah, we want to do with the arithmetic before it makes the cast.
yeah, so
In case you're doing a double
returns-
versus an int, and that doesn't make any sense.
Or would it do the arithmetic first with its own casting for the arithmetic, and then when it goes to put the result into float, it casts it to float,
Or
This-
get an error, I guess?
or an error? So maybe what we could do in next class is how would we code this up if we wanted to know the answer? And actually, this might even be compiler dependent. But if we wanted to know the answer, what would we, oh no, we can take the template as I had it, and then take this code and compile it, see if it compiles, and then could we figure out if the answer came back as 2, that's not the minimum, right? It's 1.8 is smaller than 2. If the answer came back as 2, we would know the double got casted to a long, which gave a result of 2 from the min function, which then filled into the float. But if it looked at the float, the return type, it would cast both of these into floats, do the min function, and then return 1.8. But you could kind of see now, like with the different types, if they don't line up exactly and then the compiler starts doing implicit casting, you might not get the results that the person who wrote the template wanted, and then you're the user of a template and you don't even know how they wrote it. And then the compiler's doing casting for you. So it's just something to keep in mind.
But that would work for the template if we made sure they all had different values. They're not all type.
Yeah, if we, instead of using TTT, if we had used TUV,
It would work.
they tend to start with the letter T and then they just go, I think they go through the alphabet. Yeah, so if we had done something like this, T, U, and V in the template heading, and then defined it here with T, U, and V, then it's like we're saying we don't require that they match. And then in that case, what would happen? This computation would get done, that was the long against the double, which, if it's okay that the types mismatch, would 2.0 and 1.8, would one get casted to 2.0 before it was computed? Would it be the left one, the right one gets casted to the left one's type, and then the computation is done? Or would it just leave the types alone? It's like, in other words, if you said a long is a long less than a double, will there be any typecasting or would there not be? And then it would become false, right? The 1.8 would be lower. So the 1.81 would get returned to the float. So in that case, if we did say T, U, and V, the function would work fine in that case. And then there wouldn't be any issue, there wouldn't be any warnings. We're gonna get, if we don't compile by using T, T, and T, if that doesn't compile, we're definitely gonna get warnings. You always get warnings when there's implicit typecast, because you might be losing data. So we're gonna get at a minimum warning. So then if somebody started, if one person wrote a template, and then you bought the template from the person and started using it, and you didn't make these match exactly, you're gonna start getting warnings in your compiler. You're like, I didn't even write, why am I getting warnings? So you have to realize what they may have done. Okay. Okay, and suppose, like we had talked about a couple classes back, suppose we made our own class called ratio. And if you remember, our ratio had a numerator and a denominator in the private or protected field. And we created a constructor that would write the parameters to the ratio. So this is a ratio of 2 divided by 3. And here's a floating point of 0.8. And now suppose we call min. Would there be any issues here? Would this compile or not compile?
On the first one, no, but on the second one, yes.
The first,
Template, if we kept them all consistent with being T.
if they were all T's,
Yeah.
it would not compile. Because a ratio and a float, it can't figure out what's, wait, why wouldn't that compile?
Are we converting our ratio to decimal, to float point?
Well, so the ratio is not a primitive type. The compiler didn't give us that. We defined it with a class definition. And so now the question is, oh, if in our class definition we had a way to
Yeah, like if you can call.
say its value?
Yeah, if you can convert 2 divided by 3 to a float, then it would be fine. But you have to call that method. But
Yeah, right, and so we'd have to have a, well, right now, we're not calling a method to say what is its float equivalent. We're just passing it in
yeah,
here. So the types don't match, but does anyone have just a thought, would it compile, not compile, if it ran, would it run?
You'd probably get an error saying you can't compare them because they're two different.
Yeah, the
data.
issue would end up being, the comparator's not here. This is not the you'll get an error that says something like, you know, less than doesn't make sense for a ratio. So the compiler errors might get a little bit confusing because you're calling the min function and it's complaining about ratios not having a less than, and you might not even see this code. It might be a library you're including, and you'll start getting that in your compiler errors.
can you do like an operator overload then?
Yeah, that's what you'd have to do. So if you got that, see, that's the thing, when you start buying other people's templates, and it ends up making sense. There's a lot of big templates out there for us to use. But if we start using them in ways that they didn't intend it, we start getting compiler errors like comparator less than doesn't make sense for the type you declared. And then you would have to know, oh, that must be in the templated function, they're using a less than operation, which we can't see, but obviously they're using it because we're getting compiler errors from it. And then whatever it is we've introduced, the compiler doesn't know how to do a less than, and then we would know to overload the less than operator, and then it'll start working. So yeah, that's exactly it. That's what, like, I just wanted to point out some of the things that could go wrong, and then you just suggested the way to get around that one. Okay. Yeah. So, I don't know if you guys taken a data structures class, or even, doesn't bubble sort come up in the discrete math class?
Yeah, and 170, right, the
Yeah,
first
it's-
computer science class you ever had.
Okay, yeah, so it's a pretty famous, even if you haven't taken a data structures class where a whole bunch of sorting algorithms will come up. This is kind of a standard algorithm for sorting things. So it's basically you have an array and you look at the first 2 elements and you swap, you know, put the bigger one on the right of the small one, then go to the next 2. And if they need to be swapped, you swap them, and you work your way up to the end. So after one pass, you know the biggest element is at the end. Right? Now you go back to the beginning and do it again. And then for the second pass, the biggest one is at the end, the second biggest one is second from the end. Then you do it again. So you do this n times, and then you have the whole thing sorted. So they call it bubble sort because like one is bubbling over the other one, I guess. Okay, so suppose you wanted to write a sorting algorithm, and you're gonna sort a lot of things. Integers, floats, anything you can, again, have a less than. Do we use less than? Oh, we use greater than here. So anything where greater than is defined, and the swap function has to make sense for it. Okay, so in this case, we have two template functions, and one template function makes use of another template function. So here what we're trying to do is we're trying to create a bubble sort that will bubble sort anything. Not just integers or floats, but anything you give it, it can do a bubble sort. So the first function, I'm saying template class T, and it's a swap function. Basically, if you give me two things and ask me to swap them, I'll swap them. That's what this function does. So we have a type, whatever the type is, a reference, x and y, so an x and y come in. Then we create a temporary one, we assign x to it, y gets assigned to x, the temp gets assigned to y, and now they've both been swapped. This swap works because we're using references. X and y are just another name for the fields put in, so the data actually would get swapped. Okay, so this is a swap function. Now, and it's a templated function, so the type can be any type we want. Now I come down here, and I kind of did this just to make a point. I used T again. I didn't have to. I could have used another letter like U, but this T and this T are two different T's. So I kind of wanted to do that just to make that point. When you say template, when you declare a template line, the very next line of code, which ends up being the entire function, because this void starts here and ends here, that T applies to whatever comes right after it. Once we hit this closed paren, the T doesn't apply anymore. Now the fact that I happen to use T again, this T applies only here. So this T and this T are not necessarily the same, but I could have avoided the confusion by making this a U or any other letter. But this T and this T are two different things. So now this template function does a sort, and it takes in, it's basically the algorithm for sorting. You go through the array 2 times, and if one is greater than the other, then you call swap. If the one on the left is greater than the one on the right, then you swap the two. And then run this so many times, and the list will be sorted by the bubble sort. Okay, so now we get the idea, it's not just like the min function, we can actually write bigger functions, and now we're sorting anything, any type that there is. So what would make this work or not work? Basically, if whatever the type is, if greater than makes sense, and the two things are swappable, which pretty much everything is, this function will work. So again, if we try to make an array of those ratio things, we'd have to overload the greater than for this to work. This could have been rewritten with a less than, so it's almost like you have to compile it to see which operator you need to override. Okay. So we just talked about templates for functions. Now we can also do templates for classes. So the way a template for a class works is basically your header is going to again say template. You're going to say class T and then start putting in your parameters. You can build a list of them. Then, like with the function, right after this became the function's definition. Now we're going to do the class's definition. We say class, the name of the class, and then open paren, and we describe the class. The list of the parameters for the types can be peppered all over the class definition. And we can also, like before, we can say class T and then a class U. We could also throw in integers. So for example, if we were making a class like an array or a linked list, we can put in like the size of it, so integers can be put in too. It doesn't have to just be parameterized types. Okay. Now, this is just one kind of side thing to remember, that the primitive types have to be constant. And I think this will just be, it'll make sense to you intuitively. So for example, we could do this. we can say template, class T and an integer n. And then we say class, and now we're gonna describe the class. We have class and an open paren and closed paren, and we describe it. And maybe n is used to build the class. So it could end up being a linked list of size 10, you know, with n being 10. So at this point, if we wanted to declare one of these objects, normally when you create a class and you want to declare one, you say the class name space a variable's name, right? Now, because we don't know what type it is, we have to somehow say the class name and the type space the name of it. So we would say class name, and then its type should be floating with a 22, and then here's its name, x1. This would be okay because 22 is a fixed number. The compiler knows at compile time, whatever I'm doing with x, I'm making 22 of them, or it knows the number to make. And then just a little bit of review, C++, you could say constant n, a constant integer n. That means you're assigning the value n for the remainder of the program. It can never change. It's a constant. So we could say constant n equals 44, and then we can make a class definition, x, of characters with the amount n connected to them. And this would compile okay, and we give a name. But if we did something like this, if we had a variable where we say m equals 66, and then try to create a class, instantiate something of type x with short and m as type parameters, the compiler doesn't know at compile time what the value of m is. I mean, you might think it can read it, it's on the line above it, but let's say there was a big, it started off m is 66 and went through a couple of if-then else statements and the compiler can't figure out its number. The compiler wouldn't know how many things to make. So the compiler doesn't allow the numbers that we're putting in to be variable. They have to be known exactly what they are at compile time. So I just hope that's kind of, intuitive. I don't like memorizing things, but just the idea that if you're using a parameter and the parameter is some number, it has to be the compiler needs to know at the time it's making the class that it has to know what the number is. Because that would mean, like, if that wasn't true, the compiler could make the class and then you could change them, and then the class definition would have to change in the middle of your program, and it can't do that. Okay, so then member functions within a class are very similar to the functions we did that are outside of the class. So in this case, suppose you wanted to create a function called, create a function that squares a number. You give it a number and it'll give you that number times itself. So you could, if you wanted to, and this is just a side note, if you're using a programming language like Java or C#, if you wanted to make a function that squares a number, just because you'll be needing to square numbers, let's say, how would you do that in one of those languages? They require that everything is contained inside a class, right? C++ doesn't do that. C++ allows you to write a function that's just sitting out there randomly. But in Java or C#, you'd have to actually put it in a class. So what you end up doing is you create a class, give it some name like math functions, and then start writing functions in there, and you make them static functions. So just a little review of what a static is. A static is something that applies to the class, not to an individual element of the class. So it's a little bit of a headache in Java. If you wanted to write a function that just squares a number, you have to actually create a class called something like math functions. Or I think math is the one they just call it math, right? Where they put all the static functions in. So you'd create a class called math functions and then start putting in static functions, and then if you wanted to call one, you would have to say, class name, you'd have to say math functions dot square. No big deal. But in C++ we could do the same thing. If we wanted to call a function that is within a class, so this would mean it's like a member function of that class, then what we could do is we could say, again, we have template class T, now after that is a class, so this is a class template, not a function template. I'm saying it's math functions, and then I'm listing a function called square. it takes in a number of type whatever, multiplies t times itself and returns that, so the types match, and then I could just call it exactly the same as if I declared it this way. So this is a case where multiply has to make sense to whatever the type is. So if you called square with 2 characters, I don't think a character times a character is defined. You could double check that, but I don't think they'd convert it to an integer, multiply, and then give you the new character back. So chances are, if you call this on a character type, you get a compiler error.
Yeah.
Saying multiply doesn't work for characters. Okay.
Z minus X.
Okay, then this is just a little thing where if you start debugging problems when you're using templates, you might start seeing types that you didn't create. The compiler is creating them for you. So, for example, if we define that math functions thing, that class, then I could say I'm making a math functions of shorts, and I'm calling it X. You create this object. The compiler will make a type for you. So again, what we did was we created a class, a template class called math functions. And we could do math functions of shorts, we could do math functions of doubles, we could do math functions of anything where multiply makes sense. So now we go ahead and we say, I want to make X be a math functions of shorts, called X. Then you compile stuff and you start getting compiler errors. You might see something that says, there's a class called math functions underscore short. And you say, I didn't make that. You start seeing compiler errors that says there's a class called math functions underscore short. But the compiler made it for you. So that's what, the GNU compiler does this, and I don't know if they standardize it that every compiler should do this, but you'll see this type. This is the type that you made. So it's math functions underscore shorts.
So if you were to pass an integer, then it would say math functions underscore int.
Int, right. And then you might start seeing compiler errors that say the class math functions underscore int has a problem, and you're like, I never heard of them.
So
I never heard of that, but you made it
Yeah.
by using someone, it's either yours or someone else's template, and then saying of type short, and then it starts making them for you. So this is kind of, I'm just pointing out in case you start seeing this, it's the compiler generated the type for you. So now as soon as you make one math functions of shorts, that type now exists, that class now exists. And then if you start making objects of that, you might start getting compiler errors about them, and the compiler errors print out the name of the class. Yeah, and it's not guaranteed that it'll be underscore short, but it seems like all the compilers do that. And then obviously if you start having multiple parameters, it'll just start doing underline and building that. Okay. So now, has a stack come up in,
Yeah.
This is where we use generics. Like, this is the only time we use it, was when we were creating stacks. And
in
So
Java?
you
Okay.
would like,
Yeah,
implement the
structure.
stack interface and then, use the generics to store a stack of integers.
So, okay, but you were making a stack of anything,
Yeah.
and then saying, now I feel like doing a stack of integers, but, okay. So yeah, this is basically the same idea, so this is just an example of a different data structure. So now we're making a class, and the class has several operations and some data, and now we get a little better appreciation of why you'd like to just do this once, and then you could use it for every type that there is. We're just stacking stuff up and popping stuff off the stack. So I think in this example, it's a good time to just review some stuff we know from the past anyway. So we're saying template, class, we're parameterizing the thing we're gonna make a stack of. And then we're saying class right after it. So it's either, whenever you say template class T, the next thing after it is either a class definition or a function definition. Because that's all C++ allows you to do templates of, functions and classes. So this is a class called stack. In the public section, there is, so this is a good time to do a little review. This is the constructor, stack. What does this mean? Int s equals 100. There's a parameter S. If you don't supply it, we're gonna make it 100. But you can say how big the stack is. But if you don't tell us, we'll do 100. This is the initialization list from here to here. Whatever you're giving me as S, I'm gonna copy that over to size, which is the size of the stack. That's in our private section. I should have made this protected in case somebody wants to inherit. Would you ever inherit from a stack? To make a special kind of stack? I don't know. Anyway, it's probably good practice to make this protected in case somebody later on wants to inherit. But, okay. So now we have the size of the stack gets copied over. The field top, the top of the stack, always starts off as -1. There's nothing on the stack. And then we're doing something you might not have seen in Java. We're creating an array of whatever the thing is, and the size, whatever the person initiated it as, will be the size. When we do a new, so this is now on the heap. This being on the heap means the close paren that you hit will not make it go away. You have to actually go out a few ways. So we're going to create a new, an array of size, and the type is whatever the type of this stack is. Okay, now, wiggly line, name of the class was the destructor. This runs anytime an object goes away. Usually, if all we're doing is getting rid of the storage, we don't have to do anything because the storage automatically goes away when we're finally done. But in this case, we use the keyword delete, and we actually want to delete the array. So what's really happening here is there's 3 elements to this object. The size of it, the top of it, and then a pointer to an array of storage. The array of storage is not actually part of this class. It's something we got, and we have a pointer to it. So if we went away and didn't delete the array would still be around. So as part of our destructor, we actually delete, and this means the entire array pointed to by data. Okay, so we delete that array, and then these 3 fields get deleted away. So that's why we had to add something to the destruct. Okay, and then we have the standard, actually I didn't write a whole bunch of them, but just enough to make the point. We have the push operation, where we take the top of the stack, increment it by 1, and then put the new item into the array.
What's CONST?
Oh, okay, this ends up being a constant, and that's basically saying that when this gets passed in, it will not be changed.
Oh, okay.
So, do they have constant in Java?
Final, I think.
Yeah, it's final, right?
Yeah.
Final, okay, yeah, constants are finals in Java. Okay, so yeah, that basically means it won't be used, it won't be changed during the processing of this function. And then the pop routine, in this case, there's 2 definitions of pop. Actually, in the generics in Java, when you pop something, you don't decrement the stack, right? No, wait, there's top,
There's top and top.
there's a top, which gives you the top of the stack, but leaves the pointer at the top. And pop lowers it, but doesn't give you anything. It just, right? So if you want to read the top of a stack, I think in the Java collections, you say top and pop. You have to do a top and a pop. Top to tell you what's on top, and then pop to move the pointer down 1. Yeah, so there's 2 steps to it. So what I'm doing here is I'm doing them actually both in 1 step. Again, this was just for an example. So what I'm saying is I'm decrementing, I am returning what's on top of the stack, and then after that, so the minus after, it means after the operation is done. So I'm going to return what's on top of the stack, and then I'm going to decrement the top, the pointer to the top. And then I have an isEmpty method, which is basically saying, tell me if true or false is the top -1. And if it's full, am I 1 less than the size, because the size goes from 0 to size -1. Okay. So now what we can do is we can use templates to create a class of something a little bit more complicated, like a stack.
Why would you make a method constant? Are you saying that you can't override it or overload that method then?
Yeah,
Okay. So the constant return type equals -1? I can't override to say equals -4.
Yeah,
7.
basically, this is, I guess aside this is kind of a protective thing. If you make a method a constant, you're not changing any data in it, you're only reading stuff. You're not performing any operations, and the Java equivalent is, when you have a Java method that only reads data, doesn't alter anything, is there a keyword you can put?
Maybe just a comment, leave me alone.
What is it?
So
No,
just
there's
put
a-
comment, leave me alone.
There's a way, yeah, there's a keyword you could say in Java, I forget what it is, that's equivalent to const, but it's,
In C# you do properties and then you do read or, and in Java then you do the method get set.
yeah, there's gets and sets, but there's a keyword that says, I'm not altering anything, I'm just reading fields and returning them. I'm not saying A equals A plus 2, I'm not altering anything. I forgot what the word was.
Yeah.
But anyway, that's the idea. Okay, so once we have declared this, then they become very easy to use. So we declare it once, and then we can do it. This is just an example of something that's using it. So for example, we can say I want to make a stack of integers, and I'll call it int stack 5. So now I create an array of size 5, I have a pointer pointing at it, and there's no data in it yet. Then I can make another stack of integers called int stack 2 of size 10 if I want. Then I can make, a stack of characters, called a character stack. So now it becomes very easy to declare these things and just start calling those functions, because, if we get all the bugs out of our template, then the types shouldn't matter much. Okay, so then suppose we did something like in stack 1 I push an 11 onto it, in stack 2 I push a 22, character stack I push an A. And I think if we started pushing characters onto integers, I think it would do an implicit conversion to its ASCII number.
ASCII number.
Yeah. So I know Java does that, I'm not 100% sure. Does it too? Okay, yeah. And I don't know if that's something you want. You accidentally push a number onto a stack, on a character stack, it's converting it for you. Maybe you want that, maybe you don't. Okay, so then in this case, we can now call, functions that exist and then feed those into other functions of different stacks, and this would compile too. So for example, I could say on stack 2, do a push of stack 1, integer stack 1's pop. So what would this operation do? And this is more of a data structures question, not really a C++ question, but what would this line do? So we have a stack that has, stack 1 has 11 on it, stack 2 has a 22 on it. The character stack has an A on it. Now I'm pushing onto stack 2 the pop of stack 1.
So you-
The 11 would get pushed on top of the 22. And then if we started saying pop, output the pop of 1 and output I'm sorry, stack 2's pop, print out stack 2's pop again, and then print out is it empty or not. It should print out 11, then 21.
22, should be 20.
22? Oh, this should be 22, okay. Okay, I should have compiled this and then ran it. But anyway, okay, so this should be a 22. So yeah, so it ends up being, there's an advantage to using the templates if you're gonna do some big definition. Maybe that min function that we talked about earlier, it might make sense to just write it once or twice, because when we did the template version of it, we made tons of definitions, and maybe we only care about 1 or 2, and it's short enough. It's kind of a judgment call, but if you're going to be doing something like creating a data structure like a stack, you might want to write it as a template, and now you have stacks of anything you want, or linked lists. So after C++ introduced, I don't think this came out in the very first release of C++, but after they introduced templates, then people got the idea, oh, why don't we take all the famous templates that programmers would want, which end up being mostly data structure templates, and why don't we get a group of experts and write them, and put them in a library so that everyone can get to them. So they ended up calling, they created a consortium of like people from IBM and Hewlett-Packard and Xerox, places that had very skilled C++ programmers, and they all kind of divvied up the work, and they said they wanted to make a big library out of them, which they call the standard template library. It's usually called the STL. If you like look on job websites, they're looking for C++ programmers very familiar with the STL. You'll see that a lot. So they put this STL together, which is all the famous templates. And then people write in, hey, couldn't you add this function and that function? So hopefully over time they all got developed well enough that all the meaningful functions are there and they've been tested well enough so you know these will all work. But occasionally you get these compiler errors that if you start misusing them, you might get compiler errors, and since someone else wrote the template, it's just good to know what compiler errors might be coming to you. And then just a comparison for people who are Java or C# programmers. So Java calls what C++ programmers call templates, Java calls them generics. Java does not use the template header. And I guess if you think about it, it might be unnecessary. So what a C++ programmer would say, template class T, and then define the class with T's peppered all over the definition. The Java equivalent, you would say class stack, and then immediately say greater than, less than greater than with the T in the middle. That's kind of like, right now you know this is going to be a generic. You know the T is going to be peppered somewhere, so you know it's a generic. So I guess Java decided you didn't have to write generic on top or template on top, because as soon as you see one of these, you know it's a template, a generic, what Java calls a generic.
Professor,
Yeah.
can you have like a regular class definition and use like a generic object within that? So you have like a regular class definition person, and then maybe say like.
And then in the middle of it, you want something defined
Yeah.
for any class.
Yeah, you want like you come up with a variable, but you don't want it to be like integer or character or a specific primitive type.
I don't know the answer to that, but let's just think this one through. So,
Like
because I hate memorizing things. I like having a logical reason that it makes sense or not. So you have a class, not a generic class,
Yeah, it's
or not a
regular
template class, but in the middle of it, you have something that's template defined.
Yeah. And then after this, you would then use some type of generic. Sorry. Is that on camera?
So,
I really don't know. I'm gonna go
What do you-
download.
well,
I'm
you know-
sick, I have a concussion, that's
all
why.
right. What do you think? We can find out the
You found
answer
out?
next class. What do you think the answer would be?
down.
So basically, he's making a non-templated class definition, but in the middle of it, he wants to declare a template.
I don't see why not, but I'd worry about the scope.
But then if you made one of his things, like he said in his example, person, if you made a person, you'd have to tell, at declare time, you'd have to say this is a person of integers, or, you'd have to say what its type is. So then the fact that
Didn't we do that, never mind. We did the nodes with the linked list. Didn't we have?
Generics.
Yeah.
what I'm thinking is, and when that thing got declared, you'd have, the declarer of your class would have to say,
Oh, I got you. It's like a node of, it could be any type of node, but the whole thing, it's a main class is not a node.
Yeah.
Okay.
So basically, like for here, it's just like a regular class.
okay,
and then you
but
would-
if you made one of them, you have to say what the type that's changing is at the time you declare it, right?
Yeah.
You couldn't just make one and then somehow the compiler guesses what type it was. So you'd have, like when we said, like before, when we said, what was it? Like when I'm making a stack of characters, your thing, you'd have to declare it as a person of whatevers. Otherwise, the compiler wouldn't know what to fill in the T's with.
Okay.
And then and the way you make it required, that when you declare it, is somehow on the heading. So C++ puts it on the heading, that makes you require it. Java just basically took the whole word template class T and just moved it right here. And either way, you're forced to